Okay. Bismillah ar-Rahman ar-Rahim. Now we started this 5.1 to 5.3 and we reached the all the exams questions and we did all of these. These are examples. Then we reached all the exams questions. And by the way, those all the exams are from 161 to last term, 231. Okay. So we reached now this one. We did this one was the last one. Now let me go to the next, this one. He said, which the following set of functions of a given third order form a basis for the solution space. So to be the basis, I need three linear independent solutions. So I want to be solutions. He said set of solutions. That's it. I want them to linear independent, and I have three of them since I have third order. So this two cancelled. This is cannot be. This one cannot be because it's linear dependent. I need C1 cosine 2x plus C2 times 5 plus C3 times cosine square x equals 0. I need to find C's, not all zeros, which I think I can do. Please note I have cosine 2x equal to cosine square x minus 1. So I make this 1. I have 2 cosine square x minus 1. So to kill this, I'll make this minus 2. So that will be 2 cosine square minus 2 cosine square x minus 2 cosine square x. That will be 0. Now for minus 1, I'll make this 1 over 5. That will be 1 minus 1. So that will make it so they are linearly dependent. This is also the same, linear dependent. Why? We know if there is a set of functions and one of them is 0, then for sure it's linear independent. If I do C1 ax plus C2 e2x plus C3 times 0 equals 0, I'll make C3 1 and the rest I'll make them 0. That's it. I'm having 0. For part B, also this is linear independent. Why? I think this is very easy. C1 times x plus C2 times x squared plus C3 4x minus 3x squared equals 0. If I make this one, for the x squared, I have minus 3x squared, so I'll make C3 3, C2 3. I have 4 here, so I'll make C1 minus 4. So I have minus 4x plus 4x, this is 0. 3x squared minus 3x squared, this is 0. And the only solution which is correct is this one. This is because we have two functions only. So for sure, they cannot form a basis for the solution space of a third order linear differential equation. Okay. Now, a linear homogeneous constant coefficients with least order. This is important, least order. So it's not for any order, it's the least order I can have. Where I have this is which has not the general solution, which has y as a solution. As a solution. Okay. As I said, those were questions for Math 202. I try to change it so that it will fit with Math 208. Okay. In Math 202, they have this inhalator, which is not part of this Math 208. But I construct the function I construct the question in a way it can be for Math 208. Okay, so I have y. I need to simplify it first. I have 4 minus 4ax plus e to x times 1 minus 1 over 4 e to x. Now let me do the multiplication. That will be 4 minus 4ax plus e to x. Now minus 1 over 4 that minus e to x plus e3x minus 1 over 4 e4x. Yeah, I notice here these two are cancelled. So my y is 4 minus 4ax plus e3x minus 1 over 4 e4x. If you notice this means what? As roots. From this I'm getting 0, 1, 3, 4. So as auxiliary equation, that will be r minus 1, r minus 3, and r minus 4 equals 0. So it will be my differential equation. I wrote it in terms of the operator, d minus 1, d minus 3, d minus 4, operated in y equal to 0, which is this one. I don't need d minus 2, because it's cancelled here. And I need the least order. Okay, which has y as a solution, not general solution. General solution is C1, C2, something like this. Yeah. Okay. So my y is 10 plus 7 e3x cosine 5x. Okay. What are the roots? 10 will give me 0. C1 only. So, and it takes C1 to be 10. This one will give me what? Which root? That will be 3 plus or minus 5, because I know if it is cosine, then I have sine. So I need these. So these are the roots. So what will be the auxiliary equation? It will be r times this. I have 3 roots, 2 roots here, 3 minus 5i and 3 plus 5i. So I have r minus 3 plus 5i times r minus 3 minus 5i equals 0. So I have r minus 3 square plus 25 equals 0, which means r square minus 6r plus 34 is equal to 0, because I have 9 plus 25. So it will be my differential equation in an operator form, d square minus 6d plus 34 operated in y equals 0, which is this one. If a be x to the power n forms a basis for the solution space of third order, I have 3, 1, 2, 3. So I need these a, bx, x to be n, these to be linear independent. Okay. Also n not equal to 0. Yeah. I need n not equal to 0. Okay. Then what are the conditions to make this linear independent? For sure, I need a not equal to 0. Because if a equals 0, then that will be linear independent, this set. And also I need b not equal to 0. Okay. Now when it comes to the powers, I have what? I have here a x to the power 0, b x to the power 1. So I need n to be not either 1 or 0. So also I need n not equal to 0 and n not equal to 1. If I have all of these conditions, so I think I need, this is, I think it needs n not equal to 0. So if I have all of these conditions, then for sure, this set will be linear independent. Will be linear independent. I think what he meant, all of these cases, for sure, it will have a problem. This one, it will have a problem. Yeah, it will make it dependent. This one, b equals 0, so for sure it will make it dependent. N equals 0, so these two are the same. So it's linearly dependent. N equal 1, the same thing. So because of that, this is the solution. But for completeness to have a complete solution, complete conditions, I need all of these 4 conditions. Okay. Which has y as a solution. Yeah, I have y equal x square minus x sine 3x. When I can reach x square, if I have how many zeros? Roots. I have 0 3 times. Because I have C1 plus C2x plus C3x squared. So C1 and C2 can be 0, but C3 is equal to 1 to reach x squared. So I need the 3 zeros to reach x squared. And here I have plus or minus 3i, but because of x, I need it 2 times. So that what will be the auxiliary equation? Here I have r cubed, and here I have what? I know this is the r minus 3i, r plus 3i for one of them, all squared, by the way. That will be r squared plus 9. So I need r squared plus 9 for one of them, for the 2 squared. That will be the auxiliary equation. So it will be the differential equation, d cubed, d squared plus 9, all squared, operating in y equal to 0. Let y equals C1. Okay. This is the solution. This is the general solution. I need boundary condition. I have a condition here. I need to find C1 and C2. To see, can I find C1 and C2 or not? Yeah. Let me check. Substitute square root by the way, if x equals square root pi over 2, then what will be x squared? It's pi over 4, which we know how to deal with. Okay, so I need y prime. Y prime will be what? This will be 2x C1 cosine x squared. It will be cosine x squared times x squared times the derivative of x squared, which is 2x. This is minus 2x C2 sine x squared. Okay, now let me put the conditions. Y square root pi over 2 is equal to square root of 2. So I have what? Substitute in 1 and in y. I have C1. X squared is pi over 4. Sine pi over 4 is square root 2 over 2. Plus C2 square root 2 over 2, because sine pi over 4 is the same. Square root of 2. Multiply by 2 over root 2. That gives me what? C1 plus C2 equals 2. That's really my first equation. Now for the second condition, which is this one, what kind of equation I get? Yeah, be careful. I have 2 minus the square root of pi over 2 C1 cosine x squared, sorry. This is square root 2 over 2 minus 2, same thing, C2 square root 2 over 2. And that should equal to 0. So multiply by what in this case? 2 over square root of 2, and also 2 over minus square root of pi. So I get what? This is everything cancelled, so I have C1 here. And this one, I have everything cancelled, minus 2C2 equals 0. Okay, so if I subtract both equations, what I will get? If I subtract both equations, is it? 2 over square root of 2 cancel. This is cancelled. I have minus 2C2. So let me put the two equations under each other. If I subtract this from this, this is minus. Let me rewrite it easily. Let me do it in steps. Multiply by 2 over square root of pi, square root of 2. I have what? This is cancelled. I have minus the square root of pi C1. This is 1. multiply by 2 square root of 2. Here I have what? This is cancelled. Plus square root of pi, there is no 2. And these two cancel, C2 equals 0. Yeah. Now multiply by 1 over square root of pi, you get what? Minus C1 plus C2 equals 0. So I have these two equations, C1 plus C2 equal 2, minus C1 plus C2 equal 0. Add them. So I'm getting 2C2 equal 2. So C2 equal 1 and C1 equal 1. So what will be my solution? I have a unique solution in this case. So this is impossible. So I have y equal, both are 1, sine x square plus cosine x square. Now I need to check y at 0. So it is y at 0, sine 0, which is 0, and cosine 0, which is 1. So it's 1. So I have this answer. And these are wrong. Okay. If these form the bases, then what I have? I need, yeah, also I need b not equal to 0, because b cannot be equal to 0. So I need this, a second order, so I need two functions. These are the two functions. And I want them to be linear independent. So for sure, I need a not equal to 0 and b not equal to 0. And this m cannot be 2. This should be different than 2. That's it. So this is what I need. Okay. A constant coefficient homogeneous differential equation has the following general solution. Construct such a differential equation. Now we give you the general solution. That's the general solution. That's everything is there. And they want the differential equation. So what are the roots from here? The roots from here are -1 repeated 2 times, but since I have C2x. And then from this, I have plus or minus 2i. So these are the roots. So it will be my auxiliary equation. It will be r plus 1 square times r minus 2i, r plus 2i is equal to 0. So I have r squared plus 2r plus 1 times what? R squared plus 4 equal to 0. Yeah, that r to the power 4, I have 2r cubed. Square will come from this and this, so I have plus 5r squared. R will come times 2, so I have plus 8r plus 4 equals 0. So what's the differential equation? The fourth derivative of y plus 2, the third derivative of y, second derivative of y, first, or y equals 0. What is this one? Okay. Find general solution to this differential equation. Then I have the auxiliary equation will be what? R cubed minus 2r squared plus 17r equals 0. I can take r as a common factor. So I have r squared minus 2r plus 17 equals 0. Yeah, I have r equals 0 for this quadratic equation equal to 0, which I can solve easily. R will be what? 2 plus or minus square root of b squared, which is 4 minus 4ac, 4 times 17 over 2. That will be what? 2 plus or minus. This is what? If I take 4 as a common factor, I have 2 square root of minus 16, which is 4i over 2. That will be 1 plus or minus 4i. So what will be my general solution? Y will be C1 for r equals 0. And for this, I need cosine and sine, e to the power x, cosine for x, C2 plus C3 ax sine for x. Okay, the solution of constant coefficient third order are this. These are the solution, which is this set 1 e to x, e minus 3x. First, he wants me to check, are they independent or not independent? Okay. A, check linear dependent or linear dependent. I'll check through the Ronskin. Let's see what will happen. You have 1, 0, 0, AX, 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 A minus 2X, or A minus 2X. That will be what? 1, cancel this with this. I have AX. That gives me what? 4 A's minus X plus 2 A's minus X, which is 6 A's minus X, which is impossible to be 0. So they are linear independent. Now, he wants me to construct the linear constant coefficient differential equation cosmic distributions. So what are the roots? The roots are 1, 0, 2, 1 minus 3. The auxiliary equation will be what? R minus 2, R plus 3 equals 0. In other words, this is R square plus R minus 6 equals 0. So it will be, which is R cubed plus R square minus 6R equals 0. Differential equation, third derivative, second, first derivative equals 0. Okay. Yeah. Verify whether the solutions are linear independent. Okay, so I need to do the Ronskin. I have, let me write the function so that will be very clear. Y2 cosine square root of 2x, y3 equals sine square root of 2x. He said they are solutions. Okay, now I need to check if they are linear independent or not. I'll do the Ronskin of y1, y2, y3. I'll do a trick here. E to x, that will be 2e to x, 4e to x. This is cosine square root of 2x, which is what? Yeah, minus square root of 2 sine square root of 2 of x. This is minus 2 cosine square root of 2x. Square root of 2 times x. Yeah. The last one, sine square root of 2 times x. This one will be square root of 2 times cosine root 2 of x. Multiply minus 2 cosine root 2 of x. Now, if I want to do this determinant, that will be very complicated. What shall I do then? Yeah, there is one thing to figure out. We know that the Ronskin, since they are solution, either it will be identical 0 for any x or never 0 for any x. So I can take any x. So I let x equal 0. What will happen when x equals 0? It will be the same if x is any other value. But since x equals 0 will make the calculation easier. So I need to do the Ronskin. Since they are solution, it means the Ronskin can be worked for any x. That give it to me 1, 2, 4. Cosine 0 is 1. This is 0. This is minus 2. Yeah. Sine 0 is 0. This is square root of 2. And the last one, this is sine, sorry. That will be sine, should be sine. And this will be 0. So now we'll do the expansion with the last column. Since it has two zeros. So I have plus, minus, plus. I have minus square root of 2. Cancel this with this one. That gives me minus square root of 2 times this, minus 2 minus 4. That will be 6 square root of 2, which is not equal to 0. So they are linear independent. Okay, solve this initial value problem. A little bit lengthy one. Okay, let me do it. I have auxiliary equation is what? R cubed minus 2R squared plus 2R minus 4 equals 0. I can take r square common factor. I have r minus 2 plus 2, r minus 2 equal to 0. So I have r square plus 2 times r minus 2 equal to 0. So the roots are equal to, and r equal plus or minus square root 2i. So what's my general solution? Y equals c1 e to x plus c2 cosine the square root of 2x plus c3 sine the square root of 2x. The same thing, okay? Yeah, this is part B actually. And the equation, no, just the said there. Okay, I need y prime and y double prime. So it will be y prime 2c1 e to x. This one minus square root of 2c2 sine square root of 2x. This is plus the square root of 2c3 cosine root 2x. What is y double prime? That will be 4c1 e 4x. Okay. Here I have what? Minus 2c2 cosine square root of 2x. And this one I have minus 2c3 sine the square root of 2x. Okay, now I'll put the conditions. Y at 0 equals 0. That implies what? I have c1 cosine 0 is 1, cosine 0 is 0. So I have c1 plus c2 equals 0. I have, let me write it. So I need the equations above each other. Y at 0 equals 0. That implies c1 plus c2 equals 0. Y prime at 0 equal 1. So I have 2c1. Sine will be 0, but this will be plus square root of 2c3 equals 0. Okay. The last one, y double prime at 0 equals 0. So I have 4c1. Cosine is 0, so I have minus 2c2. And the last thing is 0. So I call this 1, 2, 3. Let me take 1 and 2. So I have, actually, let me multiply 1 by 2. By 2, I have 2 times 1. And add it to 3. So I have what? 2c1 plus 2c2 equals 0. 4c1 minus 2c2 equals 0. Equals not 0, sorry. This is not 0. This is 1, but this is 0, yes. So, yeah, 1 and 3 are okay. So I have, from here, I have 6c1 equals 0. So c1 equals 0 and c2 equals 0. Yeah, just plug it in 1, substitute in 1. That'll give me c2 equals 0. Now substitute in 2 to get what? 2 times 0 plus the square root of 2 c3 equal to 1. So c3 is 1 over square root of 2. So what will be my solution? c1 is 0, c2 is 0. I have only 1 over square root of 2. Write it y equal 1 over square root of 2 sine square root of 2x. That is the answer. A linear homogeneous differential equation has a general solution. This is the general solution. I want to find the linear second order. Very clear. I need to find A, B, C. Okay. So what are the roots? The roots are very clear. 3 plus or minus 2i. Auxiliary equation. That will be r minus 3 minus 2i. R minus 3 plus 2i equals 0. In other words, I have r minus 3 squared plus 4 equals 0. So I have r squared minus 6r plus 13 equals 0. So what's the differential equation? Second derivative. 6 first derivative plus 13y equals 0. Which is this one? Easy one. Find the general solution of this. Hint. He gave me a hint. It's a root r equal to multiplicity 2. Okay, that's good. So I have the auxiliary equation, r to the power 4 minus 2r cubed plus 2r squared minus 2r plus 1 equals 0. Okay. So you know that y r equal 1 is multiplicity. So I'll do the scientific division 2 times for 1. Have 1 minus 2, 2 minus 2, 1. 1, 1 minus 1, minus 1, 1. 1 minus 1 minus 1, 0. That's good. I'll do it again since multiplicity 2. I have 1, 1, 0 times 1. This is 0. This is 1. 1 is 1, 0. So this is also good. So what is the remaining? So I have this equation. Is what? R minus 1 squared times this equation, which is R squared plus 1. So what are this is equal to 0. So I have what? R equal minus 1 and 1, which is I know it from this one. And I have from here R equal plus or minus I. So it will be my general solution will be C1 e to the power x plus C2x e to the power x. This will give me sine and cosine. One cosine and sine. Usually we start with cosine. So this will be my answer. Okay. Okay. This question has 3 parts, A, B, C. The 3 solutions are given by this. We have the 3 solutions. Verify they are, now he gives to us they are solutions. Now he wants us to verify they are linear independent. So we'll do the Ron skin. Ron skin of y1, this is part A. y2, y3, ax, ax, ax. I have cosine x minus sine x minus cosine x. I have sine x, cosine x minus sine x. I'll do the same trick. Since they are solution, then it can satisfy any value. So I'll do the Wronskian at x equals 0. That will be 1, 1, 1, 1, 0, minus 1, 0, 1, 0. So I'll do it with the last column. So I have minus 1. This is plus minus plus minus. 1, 1, 1 minus 1. That minus 1 times minus 1 minus 1 minus 2. That will be 2 not equal to 0. So they are linear independent. Write the general solution. Since they are linear independent right away, the general solution will be C1 Y1 plus C2 Y2 plus C3 Y3. Now he gave me conditions. So I need to find, let me put this. Let's find Y prime. Let's find Y double prime. Okay, now I need the conditions. Y at 0 equal 1. So I have what? I have C1 plus C2 equals to 1. Y prime at 0 equals 2. So I have what? C1. This will be 0 plus C3 equals 2. Y double prime at 0 equal minus 1. So I have C1 here minus C2 equals to minus 1. This is 1, 2, 3. 1, 2, 3. So if I add 1 plus 3, I'm getting what? I'm getting 2C1 equals 0. So C1 equals 0. So C2 equals 1. And also C3 equals 2. So it will be my solution will be C1 is what? 0, alas. C2 is 1 plus 2 sine x. By the way, you can check easily. Y at 0 will be what? 1. Find the derivative. you will get 0, since that 2 sine x will be 2 cosine x when you do it. Okay. The general solution of constant coefficient is this. Find the differential equation. What are the roots? Are 1, 1 plus or minus 2i. So it will be the equation. I think we did something similar. I did the same question. Let me do it. No problem. Okay. So the auxiliary equation will be what? R minus 1 square. And here I have r minus 2i, r plus 2i, which is r squared plus 4 equals 0. So you have r squared minus 2r plus 1 times r squared plus 4 equal to 0. So you have r to the power 4 minus 2r cubed plus 5r squared minus 8r plus 4 equals 0. So it will be my differential equation. The fourth derivative, y minus 2 third derivative, second derivative equals 0. That will be the differential equation. Verify these are solutions. To find the solution of this. Okay. Okay. I want to verify the R solution. So we'll do it one by one. This is A. Y1 equal x minus 2. I want to sure and satisfy this equation. Y1 prime, it's minus 2x minus 1. Y1 double prime, that will be what? This is x minus 3, sorry. So I have 6x minus 4. So now I check left-hand side, x squared y1 double prime plus 5x y1 prime plus 4y prime, y1 prime, y1, not prime, equal what? X squared times y1 prime, that will be 6x minus 2. 5x times this minus 10x minus 2. 4 that plus 4x minus 2, that will be 0, which is the right-hand side. I have this, so x not equal to 0, or actually the positive side. Okay, B, not B. I need the other function, y2, x minus 2 ln x. Yeah, a little bit complicated. Y2 prime will be what? Minus 2x minus 3 ln x plus x minus 3. Because x minus 3. Because the derivative of ln x is 1 over x, so that will be x minus 1, x minus 3. Okay. Okay, y2 double prime will be what? 6x minus 4 ln x minus 2x minus 3 times 1 over x. That will be minus 2x minus 4 minus x minus 4. So it will be 6x minus 4 ln x minus 3x minus 4. Now let me check left-hand side. Y2 double prime. Y2 prime. Y2. That give me what? X squared times all of this. That give me 6x minus 2 ln x minus 3x minus 2. 5 times all of this minus 10x minus 2 ln x plus 5x minus 2 plus 4x minus 2 ln x. This with this cancelled. There's something missing. Yeah, it should be 0. Y2 is x minus 2. Look, multiply this by x squared, I have 6x minus 2 ln x minus 3x minus 2. Correct. This by 5. This by 5. Yeah. There's something missing somewhere. This is plus, plus, plus. Let me do the calculation again. This one is what? Minus 2x minus 3 ln x plus x minus 2 times 1 over x, which is x minus 3. This is okay. Now y2 double will be 6x minus 4 ln x minus 2x minus 4 minus 3x minus 4. Sorry for that. That will be 3. So that will be 5. So when multiply x squared, that should be 5. Yeah, it should be the answer. So this is cancelled. So this is 0, which is the right hand side. That's a matter of calculation. So that means y1 and y2 are solutions. Actually, they are linear independent. So the general solution, actually, they are, you can check they are linearly independent. Check. Since they are linear independent, so the general solution will be C1, Y1 plus C2, Y2. You can check the linear independent. I think I can check it easily. Let me do it here. So I have x minus 2 minus 2x minus 3. I have this x minus 2 ln x. What is the derivative? Minus 2x minus 3 ln x plus x minus 3. That will be what? Minus 2. Now let me do the calculation right away. That will be minus 2x minus 5 ln x plus x minus 5 minus 2 plus 2 minus minus x minus 5 ln x. So it will be x minus 5. This is cancelled, which is never 0. Since x cannot be 0, actually x is positive. So they are linearly independent. Now we need to find, you need to take these two conditions to find the constants. Let me give a space, then I will stop. Okay, so what is my general solution? Y equals C1 x minus 2 plus C2 x minus 2 ln x. And the conditions. What are the conditions? Y at 1 equal 2. Y at prime equal minus 1. I need Y prime, which is minus 2 C2 x minus 3. This one would be what? Plus C2 minus 2 x minus 3 ln x minus x minus 3. Or plus, should be plus x minus 3. What minus here? No, it's plus. Good. Minus 2x minus 3 ln x. Okay. Now we need the conditions. Y at 1 equal 2. That implies what? C1. This will be 0. Ln 1 is 0. Plus C1 equal 2. Gone. Nice. Y prime at 1 equal minus 1. That implies what? This is C1, sorry. So I have minus 2 C1. Here I have this is 0. Plus C2 equal to minus 1. C1 equal 2. That implies what? Minus 4 plus C2 equal minus 1. So C2 equal 3. So what will be my solution? Y equals C1, 2x minus 2 plus 3x minus 2 ln x. Can check at 1, that would be 2, this would be 0. So I think my solution is correct. Let me stop the recording. I think we have a good number of questions. Yeah, thank you.